Welcome to Math Tutorials. In this video, we are solving every question of exercise 7.6 of Chapter 7, Integrals, from the NCERT Mathematics textbook for Class 12, Part 2. Exercise 7.6 is integration by parts. 24 questions from the classic x sine x through the inverse trigonometric pairings, the e to the xf plus f prime family, and the self-referential e to the 2x sine x with two multiple choice. Here is the list, grouped. Question 1. The first classic of integration by parts, x times sine. Take x as the first function. By parts, x times minus cosine minus the integral of minus cosine. The leftover integral gives sine. Question 2. The same shape with angle 3x. The 3's divide in twice, by parts with the cosine of 3x over 3. The remaining cosine integrates over 9. Question 3. A square against the exponential, parts twice. Each round strips one power of x. First round leaves 2x e to the x. The second strips the last x. Collect the polynomial in front. Question 4. Log as the first function, x as the second. The illate order puts log first. By parts, half x squared log x minus the integral of half x. The leftover is x over 2. Question 5. Identical shape. The 2 inside the log changes nothing in the derivative. D of log 2x is still 1 over x. By parts is before. Same tail. Question 6. 1 power higher. Log first, x squared second. By parts with x cubed over 3. The tail is x cubed over 9. Question 7. Inverse sine paired with x. Parts, then a trig substitution integral. The leftover integral of x squared over the root is a known result. Parts with inverse sine first. The known integral, half inverse sine minus half x root. Combine. The book form groups the inverse sines. Question 8. Inverse tangent with x. The leftover, rational integral splits cleanly. Parts, then split x squared over 1 plus x squared as 1 minus the reciprocal. Collect the two arctangent terms. Question 9. The cosine twin of question 7. The sign of the inverse cosine derivative flips one term. Parts, the derivative of inverse cosine brings a plus on the leftover. Insert the known integral and convert its inverse sine to inverse cosine, absorbing the constant. Question 10. The square of inverse sine. Parts with 1 as the second function twice. Each round differentiates one inverse sine. First round, x times the square, minus 2 times the integral of x inverse sine over the root, which parts again. The inner integral gives minus root times inverse sine plus x. Assemble. Question 11. The root in the denominator suggests v directly. X over the root integrates to minus the root. Parts with inverse cosine first and x over root as the second function. The leftover is just minus the integral of 1. Question 12. X against secant squared, tangent appears as v. The leftover tangent integrates to a log. Parts. The tangent integral is minus log cosine. Question 13. A lone inverse tangent, pair it with 1. The classic trick, parts with 1 as the second function. The leftover is half a log. Question 14. Log squared, parts then question 4 again. 2 rounds, first round with the squared log. Substitute the earlier result for x log x. Question 15. A polynomial times log. Integrate the polynomial for v. Parts with v as x cubed over 3 plus x. Finish the polynomial tail. Question 16. The e to the xf plus f prime pattern makes its entrance. F is sine x, f prime is cosine x. Recognize the pattern. The integral is e to the x times f. Apply. Question 17. Massage the fraction into f plus f prime. Write x as 1 plus x minus 1. The split gives 1 over 1 plus x and minus its square. Exactly f and f prime. The pattern collapses the integral. Question 18. Half angles expose the pattern. Tangent of half x is f. The fraction resolves to half secant squared of half x plus tangent of half x. F prime plus f. Apply the pattern. Question 19. The pattern in plain sight. F is 1 over x. 1 over x differentiates to minus 1 over x squared. F plus f prime exactly. So the integral is e to the x over x. Question 20. Split the numerator around x minus 1. Reciprocal square and cube appear. X minus 3 is x minus 1, minus 2. The fraction splits into f plus f prime with f the reciprocal square. Apply the pattern. Question 21. Parts twice and solve for the integral. The self-referential trick. 2 rounds of parts, return the original integral with coefficient minus a quarter. Solve the equation. Gather I, 5/4 I equals the bracket, so I is the e to the 2x combination over 5. Question 22, the last integration. The double angle collapse from Chapter 5 returns. It equals 2 inverse tangent x. Replace the integrand, then use the earlier inverse tangent integral. Twice the question, 13 result. Question 23, multiple choice. Not parts at all, a substitution. X squared is a third of the exponent's derivative. U equals x cubed gives a third of the exponential. Option A. Question 24, the final one, multiple choice. Distribute the secant. Secant plus secant tangent, f plus f prime. With f as secant x, f prime is secant tangent. The pattern gives e to the x secant x. Option B. That completes all 24 questions of exercise 7.6. In the next video, we will take up exercise 7.7 on integrals of square root expressions. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.